Oh, hello there. Today we're going to be talking about more of the double angle identities and some and different ones. So you want to make sure you have some kind of trig reference sheet handy. Let's see. I'm going to turn my camera off because I think I look like a dumbass. Okay, so there we go. Um, well, okay, so these problems are kind of missing questions, I think. So I'm going to try to infer some of the information here. So for number one, I see U's and V's, and it does not tell us what U and V is. All right, so I'm going to assume that this matches that. I'm going to say that U is 11 pi over 12, and the other one is 2 pi over 3. Somebody forgot to put that here. So let's see what we can figure out. It asks us to figure out what cosine U, cosine V, and plus sine U, sine V is. Now, one thing we're not going to do, we're not going to be plugging all that in because we might not be able to calculate some of this stuff. So, sorry, this is V. 2/3 over pi, 2/3 pi, that's a common angle that we are familiar with in unit circle. This one is not. That's where the problem lies. So we got to figure out a way to change this using identities. So what you do, you grab an identity sheet. I got it up on my phone here. This is from Pinterest, which is good for finding pictures of things to sew, pretty women, and also trig identities. So I want to look and see which one looks like this one. Okay, so I'm seeing the sum difference identities. And this one, you look, say you start cosine and cosine, and then sine, sine. Okay, so the one that matches that is the cosine identity. That's cosine of something. Now, what you will see, I'm gonna type exactly what I see here because this can get confusing. Um, this one uses thetas and stuff. I'm just gonna use A and B instead. So mine right here says cosine A B, A plus B, and has a plus or minus actually here. It puts them in one thing to save room. But then after the equal, it flips this around. Now, why am I spending time writing this all out? Is because reading reference sheet could be confusing if it's written in a way you're not used to. If this sign and this sign are opposite, that means you flip what you see. So you're seeing a plus here, which means this is going to be a minus. The cosine, some difference identity works that way. The sine one does not, and the tangent one is a little funky. So I'll get to that, cross that bridge when we come to it. All right, so let me just actually leave this here for a sec so we can refer back to it. So this one is going to be U minus V. So again, this is plus here, it's minus, so it's opposite when you work with the cosine identity. So what we're going to do is compute what's inside there. So I'm going to subtract U. It's 11 pi over 12 minus V. I'm assuming we're all familiar with common denominator, so I'm not going to spend too much time explaining that. Okay, so that is 3 pi over 12, which reduces to pi over 4. Pi over 4 we could work with. All right, so here you don't need the whole unit circle. Pi over 4, that's just 45 degrees. Okay, so you make a picture like this. You could do that, or you could just make a triangle by itself. Like sometimes I don't even use the axes. I just go like this. It's like a 45, 45, 90. And then you fill in the dimensions. So you do have to do a little bit of memorization here. You want to remember that a 45, 45, 90. You could draw it two ways. You could say this is x and x. And by the Pythagorean theorem, this is x root 2. That's silly in this case, though. Just use these numbers. Pretend that one of these sides is 1. The other side's also 1, because this is 45, 45. It's the same dimensions of sides, and that's root 2. This picture, again, memorize. You want to memorize that one, and you want to memorize the one for 30, 60, 90. Forget, just look it up. So back to this, we're saying cosine of u minus v. So we have cosine of all this. So we already figured that out. Right? So this is cosine of pi over 4. That's 45. So cosine of 45 is root 2 over 2. Which is another thing you want to memorize here. But from the drawing, you take either of these 45s. Let me take this one. The adjacent is this one, and the hypotenuse is root 2. Okay, so all your work is correct. The only thing I would say is the final step. We don't want to have a radical on the bottom. Why? Because somebody said so. One of these math rule guides. It's like grammar. So you got to do root 2 over 2. You see radical times same radical is just that number. So I would have this. So just change your final answer to make it root 2 over 2. I'm like cooking potatoes and stuff right now, so I got to check that in a minute. So I'm going to do one more problem, and I'm going to end this video. So again, I'm going to make the assumption about u and v because you don't have it in here. So you have this and this. Okay, I just realized that you're writing down the identities yourself, which is that's a good place to start. Figure out like what identity you need. So I imagine you've got a problem that looked like this to start, and they gave you the U's and V's and asked you to simplify. So based on what I'm seeing here, your U would be 7 pi over 12, and V be pi over 3. All right, so you look at this, you look at a reference sheet. So you want to go with one that has like sine A, cosine B, or sine theta, cosine blah blah, or Greek letter, whatever. So sine and cosine together. And I'm looking at my little Pinterest sheet. So some difference identities. This looks like the sine one. Right, so again, I'm going to write down like what mine says, just so you get an idea how these things could look different. This says A and B, tells me, and then well, it has A plus or minus. And then it says sine A, cosine B. Then it has plus minus with the same orientation. So this is up, whereas this one was down over here. You see this is difference. Okay, that matters. And then it's cosine A, sine B. Okay, so this one, the signs are going to match. So this is minus. So the one I'm going to pick is the one with the minus. You look like you did the same thing. So you said this must be sine of u minus b. Now we're going to plug in our u's and v's there. All right, so our u is 7 pi over 12. V is, oh, okay, I see what you did there. You skipped the step. That's good. Save yourself some work. Okay, so you did the common denominator right then and there. Okay, I'm just adding that as a separate thing. All right, so I'm going to do changes into 12. So this has to be multiplied by 4 and subtract those. So this comes out to sine of 3 pi over 12, which is pi over 4 again. And so we're going to put the same angle. That's coinciding because you had different angles to start with. Sine of pi over 4, again, that's one we want to really memorize, but you can always make the picture. The picture is the same as this guy over here. So I'm just going to use that again. So the sine, let's say if I start from this angle again, so I'm looking at the opposite, which is 1, and the hypotenuse is √2. So that it gives me 1 over √2, and we just want to rationalize that. So we're going to get the same answer as we did before, which is √2 over 2. So that's really the only thing I would do differently, right? It's just your final answer. So √2 over 2 for both. That's a terrible color. Hopefully you can see it. All right, ending this video now. I'm going to do the other one later.